So for section 2, hopefully that'll be good. And let me switch this over. Actually, Jackson, could you push just right around the corner from you? There's 4 buttons. Can you push the number 1? Thank you. So for section 2 here, oh, that's the worksheet. Let's start with the notes. We're going to start off with just the idea of how do I multiply square roots and cube roots. We'll do some review of yesterday as well. Make sure we're solid there. Multiplying and dividing square roots is actually not bad. When you multiply square roots, cube roots, fourth roots, there's one thing you have to check. And that is that the roots themselves, the type of root has to match. Let's get a little bit of vocab in here as well. This shows us the nth root of A and the nth root of B, making the nth root of AB if I multiply them together. But notice that those n's are the same. And here and here. Those n's, the number that makes it a square root or a third root or a fourth root, that's technically the index of the root. So if we want to talk about the matching, we can say the indexes have to match. And that just means, are they both square roots? Are they both third roots? Are they both fourth roots? So make sure you've got that down. We're going to go ahead and start on it. As long as they match, you put them together into one root and multiply the insides. So looking at example 1 here in the notes, multiply and simplify, we've got the third root of 3 times the third root of 9. They're both third roots. They have the index of 3 for both of them. So I can make this one big third root, the third root of 3 times 9. I actually don't want to multiply those two numbers together because my very next step is to factor it out. Does that make sense? So if I multiplied 3 times 9, I'd get 27. My next step would be to factor it into 3 and 9 and then break it all the way down. So let's just break the 9 apart. 9 is 3 and 3. So that is 1, 2, 3 threes. It's a cube root. I'm looking for sets of 3. So this is just 3. That's my answer. The cube root of 3 times the cube root of 9 makes 3. Does that make sense? Next one, very similar, both cube roots. We can multiply them together. Cube root of negative times negative is going to be a positive. 72 times 3, break that 72 apart. Could do 2 and 36, which would be 2 and 18, 2 and 9, be 3 and 3. So I see sets of 3. I see 1, 2, 3 twos. So one set of 2s. 1, 2, 3 threes. So one set of 3s. So my answer is just 2 times 3. 2 times 3 is 6. So negative times negative is a positive. So you could leave them and do that at the end, or you can do it at the beginning. They're cube roots, so they're not imaginary or anything like that. They can just be negative. But since you've got 2 of them, they end up canceling out. So then letter C, this one we're back to square roots. Square root of 9, negative 9 times the square root of 18. Square root of a negative is going to be an I. Now you have 2 options here. You can break the 9 apart into 3 and 3. Or you can take the 18 and make it 9 and 2 and take out the pair of 9s. Either way is fine. Either 2 pairs of 3s or 1 pair of 9s. Either way, you'll end up with 3 times 3 or just 9 on the outside. Square root of the 2 left over there. That would be my answer. 9I root 2. So because we've got a 9 and 9, this is my pair of 9s that comes out. And so I write it one time, right? Because I had a pair of them. If you did the 3s, if you broke both of these apart into 3 and 3, 3 and 3, You'd have two pairs of threes. You'd write 3 times 3 on the outside, but that would multiply to make 9. Is everybody good with that? Let's go ahead and do a couple of homework problems just real fast. How about, go ahead and try 4 and 5, everybody. Try 4 and 5. No, sorry, not 4 and 5. Let's do 5, 6, and 7. 5, 6, and 7 from the homework real fast. Give you 3 minutes. They should go pretty quick. So try 5, 6, and 7. So once you put them together, you're going to want big pieces. 4 times 16. Then what we're doing is just taking factor groups of both of them, breaking them all the way up to their factors, and looking for pairs of factors. Right. Yeah, the multiplication is as simple as multiply the two. The line is only because you have the square root of a negative. Anytime you have the square root of a negative number, we're going to so this one, cube root, you can just have a negative answer. We have 2 negatives, and the negative times the negative. Okay. Yeah, you should. Just you're able to do something fun. Any questions about this? Making sense of this one goes because the 8 is because the 2 times 2 times 2 is a second set of 3. So it's just that we get right. And again, just get in the habit of once you finish a couple problems, check with the person next to you. Did they get the same thing? They got something different? Did one of you just not finish? Did you not simplify? Did you miss a number? I mean, it happened to me in second period this morning. There was a 2 hiding in the little factor tree. I didn't see it. It was right in the middle. It's got to be a part of my answer. So we have to go back and put it in. And having more than one set of eyes helps to catch those little mistakes. Unfortunately, 2 5 1 1 for that. The 2 and the 5 that are left inside the multiply together. All right, let's go over a couple of these, see how we did. If I call on you, I may ask you for the answer, or I may ask you to work it out part way. If I ask you for the answer and you're not there, I may have you just work out the first step or something. So let's try 5. Cube root of 4 times the cube root of 16, they're both cube roots. We can multiply them. That's good. We always have to check that, because if they're not the same root or the same index, I can't multiply them. Akash, did you get an answer for that one? 4 is correct. That one is just 4 because essentially 4 and 16 between them have 6 2s. So that's one set of 2s, a second set of 2s. Those will both come out. 2 times 2 is 4. You could also do a set of 3 4s. That would be fine. Number 6, a few of us had some issues with this, but most of us were getting it figured out. Isaac, did you get an answer for number 6?
Not yet.
Okay, so are they the same type of root? Can I multiply them together? So when we do that, we get the square root of 5 times 50. Did you factor out the 50, Isaac? 5 and 10. Do either of those go farther? Yeah, the 10 is 5 and 2. So hopefully everybody's able to get this far. And then Isaac, do you see any pairs of numbers there? Right, and so some of us, we get here, we get the pair of 5s, that comes out, but then we're stuck as far as what's still inside. We're looking for any numbers that didn't have pairs, so the 5 and the 2, we're still inside. Multiply those together. 5 times 2 makes 10. That's my answer, 5 root 10. Does that make sense? Up and down is yes, side to side is no. Are we okay? So again, if there's questions about this, please ask, because we're going to be doing this throughout the rest of the unit. Number 7 then, very similar to number 6. Christopher, did you get an answer for 7? Yep, 3 cube root of 3. Essentially, the 9 times 9 is 4 3s. You can take out one set of 3s, but you're going to have 1 left over. Any questions with those? Yes. Which one? Number 10. Okay, you're ahead of us, but I'll go ahead and do it since you asked. Number 10, does everybody see that number 10 has a problem? You've got a cube root of 2 times a square root of 7. They don't have the same index. So you're either going to write not possible or just rewrite it as it is. It doesn't reduce. You can't multiply it. It's just the same thing. Does that make sense to everybody? All right, so let's go back to the notes now. And let's take a look at letter A here in example 2. This is actually straight review from yesterday. This is just making sure we're good with simplifying before we go on to the multiplying and simplifying. So if I'm looking at the cube root of 54x cubed, let's take that 54 and break it apart. How does 54 factor? Bella, how would I factor 54? Or what's a number that goes into 54? 6 does. And again, you guys, if you're ever stuck, just grab a calculator, start dividing until you find something that goes in evenly. 6 does go into 54 9 times. So break those two apart for us, Bella. 3 times 2, 3 times 3. So we've got it all factored out. Do I have a set of 3 numbers that I can take out? Right, we got 3 3s. So we can take the 3 out. 1, 2, 3, those all come out. But I do have 1 left over. I've got this 2 that didn't have a pair, or in this case, a set of 3. So inside the cube root, I'm going to leave 1, not 3, 1, 2 behind. Then the x's. Not here today. Not here today. I just called on you. How about Izzy? Cube root of x cubed. Can I take a set of x's out? Any extras, or is one set, or just one set? That's exactly how many I needed. There's no extras. Take that x out. So 3x cube root of 2. Does that make sense to everybody? 3x cube root of 2. It's a cube root. I do not need absolute values. Put negatives in, get negatives out. Everything's fine. Letter B, cube root of 128, x to the 7th. So that 128. you're going to start to recognize some of the powers of 2 and 3, some of the not ones that come up the most often. 128 is 2. It's a bunch of 2s. 2, 4, 8, 16, 32, 64, 128. 7 2s. Quick note with that. Any of you that do any work with computers, you'll notice some of these numbers are familiar to you. If you like the size of your iPod or your phone that you get is going to be a multiple of 2 for the storage typically. So 64 gigabytes, 128, 256. It's because they're powers of 2. You'll start to recognize those because they're going to come up a bunch in this unit because of our wanting to be able to factor and get lots of pairs. So this is 7 2s. That means I can take out 2 sets, right? 3 and 3. 2 sets of 2s. 2 times 2 on the outside, but 1 2 is left on the inside because there were a total of 7. And the same thing happens with the x's, right? 7 x's. I can take out 2 sets of x's, but leave 1 behind. Clean it up a little bit. 4x squared cube root of 2x. There's my answer. Letter C is in here just to show you a very interesting case that happens sometimes. So 64, this is a 4th root. I'm looking for sets of 4. 64, 2, 4, 8, 16, 32, 64. It's 6 2s. Again, you don't need to be able to do it that fast. You can do the little factor tree, works out just fine. But if I have 6 2s, means I can bring out 1 set. 2 goes on the outside, but there would be 2 2s left over from my initial 6. X squared, I don't have any sets of x's because I need 4. There's only 2 there. Y to the 14. How many sets of y's can I take out? How many did you think? 3. Because I'm looking for sets of 4. And so 4, 8, 12. And then if I keep going, that's 16. That's too many. So 3 sets of y's, y to the 3rd, but there's 2 left over. Now, what about absolute values? Do I have one that went from an even exponent on the inside to an odd exponent on the outside? The y's, even though there's some y's left over, this one out here still needs absolute values, because if I put a negative in here, that negative would cancel out, it would become positive. Here, this one's still fine. If I put a negative in there, it's still going to be positive. But this y to the 3rd would not be, it would be negative. And I need it to still be positive. Does that make sense to everybody? That is one of the weirdest ways that they could show you that. Most of the time, it's going to be simpler. All right, let's dive into the actual main piece of today's lesson. That was more review. You've done some of that yesterday. This next piece, this is what we're going to be spending most of our time on. Multiplying these and then simplifying them. And then towards the end of class, we'll do some dividing and simplifying. So the nice thing is, like we saw earlier, if the indexes match, you literally just multiply the insides. And then you're going to reduce it just like we were practicing. So for letter A, they're both square roots. I'm going to put them together. The square root of 45 times 35. Again, I'm not going to actually multiply those together because my very next step would be to factor it back out. X to the 5th times x would be x to the 6th. Y to the 3rd times y to the 4th. That makes y to the 7th. And now I do it just like we did everything yesterday. I'm going to factor out the 45 and 35. 45 would be 9 and 5. 35 would be 5 and 7. The 9 is 3 and 3. So I see a set of 3s that can come out and a set of 5s that can come out. But there's a 7 that gets to stay inside. The x's, x to the 6th, x to the 6th, that's 3 sets of x's that can come out. The y's, you okay? So the y's, y to the 7th, 2, 4, 6, 3 sets of y's that can come out, but one y is left over. Clean it up a little bit. 3 times 5 is 15. X cubed, y cubed, root 7y. Now, I do need to check for absolute values. They don't need to be used very often. This one, you might want to put them on the X. But look at the original problem. Remember, the whole point of putting in the absolute values is so that my new answer matches the original one. Does everyone see that this is odd for the X and this is odd for the X? If I put negatives in here or negatives in here, they're going to be imaginary numbers. I'm not going to have to work that out. The negatives don't disappear. Does that make sense to everybody? I do not need absolute values on this here because it's not going from being an even originally to an odd out here. It does become an even in the middle, but that's not what I'm checking for. I want to see if I put negatives in at the beginning, do they become positives? And they don't at the very beginning. Does that make sense to everybody? So I don't actually put absolute values on this. Typically, the only time it's going to happen. Now, if any of you are really curious about this, the difficulty level of this goes up exponentially. There's all kinds of crazy extra cases. I'm teaching you the very, very basics of it. What's going to be on our test? If you're going to go on to advanced math, they'll go in a little bit more detail with this. Know that the general idea, the purpose of this is to make sure my answer matches the original ones. And really, the only way to be sure about that is to plug a negative in and see what happens. Does that make sense? And then make sure that my answer matches here and here. Is everybody okay with that? So for us, because these are not even, I don't have to worry about it. I don't need absolute values. Let's look at B, and then I'll have you guys try a couple. B, cube roots, they're both the same type of root, so I can go ahead and multiply this. I'm going to multiply the outside pieces. Negative times 2 makes this -2. Cube root of 3 times 15. I have 4 x's and 3 more, so x to the 7th. Y squared, another y, so y to the 3rd. So again, anything on the outsides get multiplied together. Anything on the insides get multiplied together. And then I factor and simplify like normal. So the 3 and 15, 15 does have a 3 in it, but I don't have 3 3s. Does that make sense to everybody? I actually can't take out any numbers from this one, but I can take out some x's. X to the 7th has 2 sets of 3. So I can take out 2 x's, -2x squared can come out. And 1 set of y's can come out because I have y to the 3rd power. However, left inside that cube root, I still have the 3 times 15. Nothing came out of those. And then the x to the 7th, I took out 6 x's essentially, 2 sets of 3. There's still 1 x left over there. So my final answer here is going to be -2x squared y cube root 3 times 15 is 45x. And that would be my answer. -2x squared y cube root of 45x. I should leave a bigger gap here. I left a little one. But again, try to leave a big enough gap that it's obvious it's not y to the 3rd power, but it's the 3rd root of what comes next. All right, I want you guys to try some of the ones from the homework. Try 12 and 14 right now. 12 and 14 from the homework. Yeah, go ahead and sign out. it's making sense, Jason. Where'd you get them from? Go ahead and go back to them. Cool. And if you're not sure, raise your hand, ask me, ask somebody else at your table, help each other out. Let's see if we can get 12 and 14 done. Oh, you really double check that and then double check the 16. So that's this. See, right? There's 3, 4, 2. But that 1 set 3 would come out. 6 times 2. Still have 1 set. You got 4. Let's have 3. That comes out. 1, 1, 1 set is 1, 2. One outside of this, 2 left over. 5, get 1 set of 3, 4 left over. So why is it doing first set of 3? You have a set of 2, why? Try somebody else here. All right, so number 12. Let's try this one, see if we can put it together. First off, are they both cube roots? Do they match? Can we multiply them together? Yeah, let's get everybody's attention here. And again, I know it's hot in the afternoons here. It's not nearly as bad as in the mornings when the heater's going. Luckily, it's switched over to cooler air, but please keep your masks on the whole time. I know it's not the most fun thing, but we still got to do that, especially with a decent number of people that are out right now. Rather keep everybody here. So for number 12, is everybody seeing that these are both cube roots? We should check that every time to make sure that we can actually multiply them together. So once we decide they're both cube roots, we can put them together. So starting off on the outside, the 3 times 2, let's start with an easy question here. 3 times 2, Jack, what does that end up being on the outside for right now? There we go. We got 6 out there. And then the cube root, we can put everything together inside. So we got that 16. How many x's are inside there then? Oh, not here. Akash, how many x's? Yep, x to the 5th. And then Devin, how many y's? Yep, y to the 3rd. And now we're going to look for sets of 3. Don't forget to break apart the 16. Take that 16, break it all the way apart. 4 and 4, 2 and 2, 2 and 2. So we've got 4 2's. What can I actually take out of the cube root then? Find someone that's here. Nope. Oh, Christopher, what's something that we can take out of the cube root here? Okay, we can take out 1x, and then how many are left inside? What was that? So I think it should be x to the 5th. And yeah, so 2x is left inside. Sorry, that was hard to read. So x squared left inside. And then Izzy, what else can I take out of the cube root there? Do you see any other sets of 3? So we took out the x's. How about the 2's or the y's? Do we have any sets of 3? So if we have 4 2's, do I have a set of 3 2's in that? Does that make sense? So we can take out 1 set of 2's, put that on the outside. Were there any 2's left over, Izzy? 1, 2 left over. There we go. So that's right. Now let's deal with the y's. Kalia, can I take out a set of y's? Any left over? Nope. So just like that. So my final answer here, 2 times 6 is going to be 12. Actually, I'm going to write it over here. 12x y cube root of 2x squared. There's my final answer. It's a cube root. I don't need absolute values on cube roots ever, so we don't even have to check. How about 14? For 14, let's go ahead and put them together. It is a square root, so we can go ahead and do that. 5 root new 2 times 2. Let's make sure that's not 22, but 2 times 2. How many c's are in there? Adrian, how many c's do we have? C to the 4th. And then for the d's, Isaac, how many d's are in there? Yep, d to the 7th. So now what can I take out? It's a square root. I'm looking for sets of 2. Samuel, what can I take out of here? How many c's? Yep, 2 sets of c's. Any left inside? Nope, they all came out. So we've got a 5 outside right now. C squared is coming out also. No c's left over. Tim, what else can we take out? Yeah, so you can do d to the 3rd power. Any d's left over inside? 1 d left over. What about the 2's? Not here today. Zach, can I take out any 2's? Yep, 1 set of 2's. That's right. And I think that's it, right? So we end up with 2 times 5 is 10. C squared d to the third square root of d. Now, talk with the people at your table just real fast. Do we need absolute values on anything? Is there any variable that went from even to odd? And the trick is that you look at the original one and they all have to be even. They all have to be even, except in weird cases, which I'm not going to test you on. Again, if you're curious, I can show you the weird ones later on. But for us, they both have to be even. Does anybody think that I need absolute values here? We don't, because again, the d's, this is d to the sixth, and it goes to d to the third, but there's a d over here also, and that one's odd, and it doesn't come out. Yes. No, you do it at the very beginning, because remember, the idea is I want my answer to match the original. So even in the middle stages, like if we started here, then yeah, I'd need, oh no, because of that, that's the 7. Yeah. So nope. Any questions there? So no absolute values needed because none of them go from even on the inside for both of the variables. Again, whichever one we're looking at. So for C, they're both odd to begin with. Don't really have to worry about those. The D's, one's even, one's odd, ends up being odd on the outside. But again, there's still one left over on the inside. So back to the notes, everybody. Let's go ahead and do letter C real fast. Let's do C and E as a couple more examples. So letter C, 3 times the 4th root of 27a to the 7th times 4th root of 6ab to the 3rd. They're both 4th roots. We can do this. The 3 stays outside. 4th root, 27 times 6. A to the 7th and another a gets me a to the 8th, b to the 3rd. So here, take that 27 and 6, break them apart. Let's go ahead and do that over here. 27 is 3 times 9. Should be 3 and 3. The 6 is 3 and 2. I'm looking for sets of 4, and I have one. I have 4 3s. 1, 2, 3, 4. Those 3s would come out and join the 3 that was already out there. So 3 times 3 on the outside. Then the A's. Oh, no, before we go any farther, let's put that 2 that was still inside the 4th root. Let's not forget about that one. 4th root of 2. A's, I have 8 of them. That's 2 sets of 4. Does that make sense? So an a squared on the outside. And then we've got b to the 3rd. It's not enough to take any out. Does that make sense? So I'm going to leave all the b's inside. 2b to the 3rd. And I think that's it. 3 times 3 would be 9. 9a squared, 4th root of 2b cubed. Anybody see anything missing? Anything we skipped? I think we're good. So look down here then at E. It's a square root. The 5 is on the outside. That's going to stay on the outside for now. So again, everybody, we're skipping letter D right now. We're going to go, go right to E. 5 is on the outside. Big square root of 2 times 4. I have 1c and another 4c, so c to the 5th. D to the 4 and 6 makes D to the 10th. So now I'm gonna look for any pairs of numbers. 4 is 2 and 2, so I have a pair of 2s that can come out. They'd get multiplied by the 5 that was already out there. So 2 times 5, 5 times 2. The C's, oh wait, before I go on though, I do still have 1, 2 left inside that square root. Don't forget about that too. The C's, C to the 5th, I have 2 sets of C's, right? 5, 1 set, 2 sets, 1 left over. So C squared with 1 C left on the inside. And the D's, 10 D's, that's 5 sets of 2. D to the 5th. Clean it up just a little bit here. 5 times 2 would be 10 C squared D to the 5th root 2C. Do I need absolute values here? Where? On the D. Because look at the beginning. D to the 4th, D to the 6th. Those are both evens. If I put negatives in there, they disappear. But if I put a negative in here, it does not disappear. D to the 5th would still be negative. So I need the absolute values to make a match. That is going to show up a couple times on the homework. If it shows up on the test, it'll be an extra credit question. Okay. So you need to know it. We're going over it. It leads into what you might do in advanced math. But at this point, from now on, after this set of homework problems, we're going to forget about absolute values. We're only doing them at the very beginning, yesterday's unit, yesterday's section, and the first half of today's section. From now on, if you look at the instructions, they will usually say assume all variables are positive. And that means no having to worry about absolute values, because it gets even more confusing if you're dealing with the division and the adding and subtracting. We're not going to touch that this year. If you have more questions about it, let me know. I'd be happy to explain the next steps for it if you want to. We're not going to do that right now. For us, this is as hard as it's going to get for the absolute values. All right, we're going to do a couple problems from the homework. Let's try. Actually, no, we've done enough practice there. I'm going to show you one more and then have you try something that's a little bit different. Everybody look at F. Look at letter F here. This one, I don't really like that they put it in this section because it's got an addition in it, and we're not touching addition until tomorrow or Friday. What you need to know for now is that you can't add those because they don't match. So just know that on the homework, you're not actually doing any addition yet. We're going to save that for the section on addition. What they want you to practice here with letter F is the distributive property. They want you to do square root of 5 times the square root of 5. That would be the square root of 25, or 5 times 5. And then the square root of 5 times the square root of 15. And then in between those, I should have left more room, is still the plus sign that we had before. Still a plus sign right there. The idea would then be to go ahead and reduce both of those. So the square root of 25 would be 5. Plus sign changed colors. 5 plus here 5 times 15. That 15 would split into 5 and 3. So I could take out a pair of 5s. 5 root 3. For now, just know that you cannot add those and that is our answer. Really, the only reason it's in here is because they want you to do the distributive property and simplify those two separate ones. But it's a little bit unfair that they're showing you pluses and minuses here before we've actually talked about them. So just know that don't do any adding or subtracting. Do this distributive property and simplify those. Everybody try number 18 right now on the homework. 18 is exactly like that. A little bit more simplifying. Oh, 18 does have something kind of weird with it. Do the best you can. Ask if you have questions. Check with your group, and then we'll go over it in 1 minute. Really, let's do that one quickly. When you're done, you can check your work up here. Went ahead and put the answer up. Yeah, sign out, take the pass. Any questions with that one? All right, let's go ahead then and move on to division. So for division, no more worrying about absolute values. Yeah, just sign out and take the pass. The trick here is there's actually multiple ways to do division. You can do it in different orders. Sometimes one order is easier than the other. It's often hard to tell which is going to be better before you start. So you can choose which way works best for you. If you get used to noticing certain patterns, you'll be able to tell, oh, this one's going to be easier if I do it this way. But you'll always get the right answer as long as you follow the steps. So if we're dividing, the first thing to check is they have to have the same index. So they still have to be both square roots or both third roots. If they are, you can put one radical divided by another together into one big radical. So a square root divided by a square root can become one big square root with the insides divided. So like this one, the square root of 50x to the 6th over the square root of 2x to the 4th becomes the square root of 50x to the 6th over 2x to the 4th. So there's one big square root that then we can simplify the insides of. 50 over 2 reduces. 50 divided by 2 is 25. X to the 6th over x to the 4th. Think back to what we did last semester. I know this wasn't most of your favorite units, but we're still going to be using fractions. 6 and 4, 6x is on top, 4 on the bottom. 4 of them will reduce. We'll be left with just x squared. This is all inside a square root. So then the square root of 25 is 5. The square root of x squared is x. And again, no worrying about absolute values for division. Are we okay there? Yes, Maha. So that was x to the 6th divided by x to the 4th. Now we're going to go over exponent rules again in a couple units or in a couple sections. But if you want to write it down now, it's actually kind of a good idea to have these in your mind. If I have x to the a divided by x to the b, that is x to the a minus b. You can subtract the exponents. Does everybody remember learning that at some point? Some of you, if not, if it's new, we're going to come back to that. But yes, that's the fastest way to reduce those. So same thing for b. Make it one big square root, 18x to the 6th over 2x squared. 18 divided by 2 is 9. X to the 6th over x squared is going to be x to the 4th. All inside a square root. The square root of 9 is 3. The square root of x to the 4th is x squared. There's my answer. Does that make sense so far? The trick is that they're not all going to reduce quite that nicely. A lot of times you're going to have something left inside the square root. And there is a specific convention as far as the way we write our answers that we're going to have to be careful of. And that is the fact that we never leave square roots in the bottom of the denominator. And we never leave fractions inside square roots if we can help it. And we can always help it. You can always undo that. Specifically, we're going to use what's called rationalizing the denominator. If I want to rationalize the denominator, that means I'm going to multiply top and bottom of the fraction by whatever I need it to have it so that the denominator of the fraction reduces, that it simplifies, no more square root down there. And that means literally if I have 1 over the square root of 2, the square root of 2 doesn't reduce. But if I had two 2's, it would. So I multiply top and bottom by another square root of 2. So that I have two 2's on the bottom that I can reduce and take out. And I end up with the square root of 2 over 2. So let's try this. Letter A here, the square root of 8 over the square root of 16. There are two ways to solve this. One would be to go ahead and make it one big square root, 8 over 16 inside that square root. 8 over 16 is just 1 over 2. 8 goes into 16 two times. So the square root of 1 over 2. I can't leave it like that because I've got a fraction inside the square root. So I'm going to break it up. Square root of 1 over the square root of 2. I can do the square root of 1. The square root of 1 is just 1. The square root of 2, though, on the bottom, doesn't simplify right now. In order to simplify that, I need another 2. But again, we learned before that you can multiply the top and bottom of a fraction by whatever I want, as long as I do it to both. Because essentially I'm multiplying by 1. Square root of 2 over square root of 2 is just 1. So this gives me the square root of 2 over 2, right? 1, 2 2's, 2 2's come out, that's my pair. I'm left with the root 2 over 2. There is another way to do this one. The other way to do this one would be to reduce both of these roots at the beginning. The square root of 8 is 3 2's. I can take one set of 2's out. 2, let's use a different color here. So the other way to do this is take that square root of 8, make it 2 root 2, over the square root of 16 is 4. Reduce those, 2 and 4 simplify down to root 2 over 2. The same answer I had before. Both methods are great. Both methods always work. In this case, the blue one was maybe easier. But I'll tell you right now, there's several problems on the homework where if you try to do it this way, it's much, much harder than reducing at the beginning, canceling stuff out, and then trying to reduce the square roots. It just depends on how the problem's set up. So it's good if you know both methods, so you can use the easier one when you notice that one is going to be easier. Letter B, I have a cube root on the bottom. There's nothing to reduce, nothing to simplify right now. I have a cube root on the bottom. I can't stop there. I can't leave that cube root on the bottom. To get rid of it, I need more 3's. If I had 3 3's, it would reduce. Does that make sense? I'd have a set of 3 that could come out. Instead, I only have 1. So how many more 3's do I need? I need 3. I have 1. I need 2 more. So I'm going to multiply top and bottom here by the cube root of 3 times 3. That way, the bottom becomes the cube root of 1, 2, 3, 3 3's. Oops. And the top just ends up being whatever it's going to be. In this case, the cube root of 3 times 3. Don't reduce anything yet. Instead, notice that we have 3 3's on the bottom. That's what I needed for that to reduce. That 3 comes out. And the top stays the cube root of 3 times 3, or the cube root of 9. Does that make sense? Let's do one more. This one's a 4th root. It's got a 1 on the top. The bottom 4th root of 27x squared. I'm going to take that 27 and break it apart. 27 is 3 times 3 times 3. Is everybody okay if I just jump to there instead of doing 3 and 9 and then breaking the 9 apart? So I have 3 3's. The x squared is going to break apart into x times x. So the trick here is I need sets of 4. I have 3 3s. How many more 3s do I need? One more 3. So I'm going to multiply top and bottom by the 4th root of 3. I have 2 x's right now. How many more x's do I need? I want 4. I have 2. I need 2 more. So I'm going to multiply by x squared inside that 4th root also. That way, the top becomes the 4th root of 3x squared. The bottom now has 1, 2, 3, 4 3s. Those all come out. And I had 1, 2 x's, 2 more x's makes 4 x's. Those come out also. There's my answer. No more radical on the bottom. Does this make sense? Sorry. Any questions with that? So let's try a couple homework problems. Go to the second page of the homework. And I want you all to try numbers 22 and 24 right now. Try 22 and 24. So I'm big class. You can do all of them if you wanted to, but I just said 22 and 24. Check to see how many more numbers you can. So like this one's a 2 root. So you want sets of 3. But you have 1 fiber. So only 4 fiber. We're going to multiply top and bottom by the cube root of 5 times 1. So the cube root of 5. So the cube root is going to be a cube root again, just like this. Do the same thing. Cube root on the top, cube root on the bottom. But with 2 5s. So 3 5s will go on the bottom. Just like that. 5 on the bottom. Now we have 1, 2, 3 on the bottom. So they'd all count. You have 1 5 on the bottom, no more cube roots. The top would just be 5 times 20. Over here, you'll have to factor that 8 out. Figure out how many numbers we have. Is it a pair of numbers? 3 is the number. Find out how many you're missing. Yeah, go ahead and sign up. Take the class. All right, let's go over those just real fast. So for 22, it's a cube root. We need sets of 3. We have 1, 5 down there right now. I know that I'm going to multiply the top and bottom by the cube root of something. Mihawk, did you figure out what goes in there? What am I actually going to multiply by? Yeah. We need 2 more 5s. Is everybody clear why it's 2 5s? Cube roots need sets of 3. I've got 1. I need 2 more. This then becomes the cube root of 25 on top. And on the bottom, we have 1, 2, 3 5s. All of it comes out, no more cube root on the bottom. That is our goal. When they tell you to rationalize the denominator, that's what they want you to do. Rewrite it so that you don't have square roots or cube roots or fourth roots on the bottom. 24. Okay. I see students every once in a while do 3 8s because you've got 1 8, you want sets of 4. You can do that, but that's definitely the hard way to work this one out. What we're wanting to do is to take that 8 and break it apart. 8 is 4 times 2, which is 2 times 2. So I already have 3 2s. Does that make sense? I already have 3 2s. How many more 2s do I need? Just 1 more. So I'm going to multiply top and bottom by the 4th root of 2. So that I have on the top the 4th root of 2 over 1, 2, 3, 4 2s inside a 4th root. They come out. The 4th root of 2 is my answer. And again, try to make the index tucked in right on there. Technically, the other vocab term, if you wanted to learn it, that symbol, instead of the radical symbol, the technical name for it is radicand. No, sorry, I almost said that wrong. The inside, what goes inside is the radicand. This, yes. So backing up a second, and again, you don't need to know radicand, that's the inside term. But if you want to have a specific name for talking about what's inside the radical, that's what it would be. The reason we got this 4th root of 2, we said that up here, the 4th root of 8 is actually 2, 3 times, 3 2s inside that 4th root. I need sets of 4, so I'm only missing 1 2. I have 3 already. So I chose to multiply the top and bottom by the 4th root of 2. I'm multiplying the bottom by the 4th root of 2 to make a set of 4. And then whatever I multiply the bottom by, I have to multiply the top by that also. Any questions with that one? All right, so let's go ahead and jump back to the notes. I'm going to do probably just 1 more example, maybe 2, depending on what we have time for. We could probably do 2, and you guys will still have 15 minutes or so to work on homework. Everybody look at letter E. Letter E, I could do this one a couple different ways. I think fastest for this one is probably to go ahead and simplify the fraction as much as you can. So again, everybody give me your attention. I know these 2-hour block periods are long and we're just getting used to being back in school after 2 weeks off. So again, keep your focus going here. For E, I'm going to make this one giant cube root of 15ab cubed over 10a squared b. And the reason I want to do it this way is because I see a lot of stuff that's going to simplify. The 15 over 10 is going to reduce. 5 goes into both of those. I'm going to end up with 3 over 2. A on the top and 2 A's on the bottom. Those will reduce for one of them. Leaves me with just 1 A on the bottom. The B's will reduce. 1 B will reduce, and I'll be left with 2 B's on the top, all inside a cube root. The problem is I can't leave it like that. I can't leave fractions inside my cube root, so I'm going to break it up. Let's actually go kind of work this way. Cube root of 3b squared over the cube root of 2a. And then I'm going to multiply top and bottom by whatever I need to make that bottom reduce. Right now it's a 2 and an a, one of each. It's a cube root. I need 3 of each, so I need 2 more of both. I'm going to multiply top and bottom by the cube root of 2 2's and 2 a's. So 2, you can write it out like this, 2 times a times a if you want, or you can go ahead and put those together, make it the cube root of 2 squared or 4a squared. However you want to do it, we're multiplying the top and bottom by the same thing. The top, we end up with the cube root of 2 times 2 times 3. Is everybody okay with me just writing that as 12? 2 times 2 times 3 is going to be 12. A squared, b squared. On the bottom, I have 1, 2, 3 2's. That set of 3 comes out. I have 1, 2, 3 a's. That set comes out. There is my answer. The third root of 12a squared b squared over 2a. I think that one's probably the fastest way to do that particular problem. You could try it another way of trying to rationalize the denominator first and then reduce. I think this was probably the faster way to do that one. See a few people still writing stuff down. Let me go ahead and show you one more example and you'll have the last 15 minutes to work. Letter F, if you can reduce what's outside, you can do that right away. You know what? For this one, I'm going to try to reduce the square roots first, just to show you a different way. So looking at this guy, does everybody see that I have a set of B's and C's that I can take out of the top? So this would become 3bc square root of 3b. The bottom, that 8 is going to be 3 2's. I can take out a set of 2's. So -2 times 2, but there'd still be 1 2 left over. B to the 4th, I can take out 2 b's, so that would be b squared. C squared, I can take out a set of c's. And look at that. I only have 1 square root of 2 on the bottom still. That's much nicer. This one, this is the faster way to do it, because I have so much that reduces inside the square roots. And so all I have to do to rationalize this, right now I've got 3bc root 3b over -4b squared c root 2. The only thing I have to do to rationalize this is multiply top and bottom by the square root of 2. So I'm going to do that. Now, if there had been a square root of 2 on the top also, I would want to reduce that right now. Then I wouldn't have to rationalize at all. Again, it doesn't matter which method you choose to use. You can get the right answer both ways. So I end up here with 3bc root 3 times 2 is 6b over -4 times 2, right? I have a pair of 2's, that comes out. -4 times 2 would be -8 b squared c. Almost done. Do you see anything that cancels out? There's a b on the top and the bottom and a c on the top and the bottom. Now, everybody's full attention real fast. I haven't explicitly said this, but you can only cancel stuff that's either both on the top and the bottom inside the square root or both top and bottom outside the square root. Don't cancel stuff from inside a square root with stuff outside a square root. Does that make sense? That doesn't work because they're not the same. So this one would reduce. I'll write the answer up there in just a moment, but you guys can go ahead and start on the homework. The homework is listed up there, 1 through 10 all, 12 through 32 even. Okay, I'll let it know. So the homework is 1 through 10 all, and then 12 through 32 even. Right. Oh, and guys, I'm going to let you in. I go back and forth about whether I want to tell my classes this or not. Look at the back of your packet. Look at the last page or two of your packet, the very, very end. The answers are in the back of your packet this time, not the note packet, the homework packet. So it's like a textbook. It's not all the answers. It's just the odds. So a couple quick things. Yesterday, I assigned the odd problems. I did that on purpose so you guys can check your work and make sure that you did everything correctly. Take some time to look through those. You must show your work to get credit. More so in this unit because you've got the answers already. You must show your work to get credit. Now, I oftentimes, because they're in the back, I'm going to be assigning evens. But if you want to check, do a couple of the odds, make sure you're doing them right, then do the evens. Does that make sense? If there's any even ones that you want to check your answer on, you're welcome to ask me. So again, the final answer for this one should be 3. Have a great day. 3 root 6b over -8b. That would be my final answer for that one.